And a big hello there to Rita and the Master Treegrower team in the Upper Goulburn. Thanks for joining. Graeme Anderson here. I'm Climate Specialist with Agriculture Victoria. Coordinate our programs that work across all the industries and making sense of climate. And I'm just going to share a bit of an update on the latest on climate change in Victoria and a few thoughts of what it might mean for tree growers. Now, I'll kick things off just by a bit of a look at the regional climate guides. So these are great little guides put out by the Bureau of Meteorology. They use data up to 2018, but basically take a look at the prior 60 years of climate records and then make a comparison between what's happened in the last 30 years and if it's any different to the 30 years prior to that. And for the Goulburn Broken, we can sort of see we've got rainfall over the longer term there from Strathbogie. You can sort of see the effect of the millennium drought there. A bit dry on average. We still get the odd wet year. Annual rainfall has decreased slightly. Dry years occur a bit more often than wet years. Rainfall's decreased in autumn and spring. Still a pretty reliable rainfall point of view from a winter rainfall region. The interesting thing that while there's been more hot days and more consecutive days above 35, we've also had this bit of an anomaly with the increase in spring frosts have been occurring a bit more often and also later. And that's often due to clearer night skies, which is pretty conducive to frost when we get clear night skies and dry air. Also, just looking at rainfall records here, so this is an example of Benalla. You can see that this is the rainfall for throughout the year, the months, January, February, March, April, May, through each of the months. This is just looking at, of the 60 years, this is the 1959 to 1988 sort of record in the dark colours, and then in the red, that's the more recent 30 years. So you can just see how that autumn rainfall has declined a lot from what it was like previously, and also just that the edge has been taken off that spring rainfall too, which certainly in some years more than others, which I'll talk about. This is a pretty common trend across parts of Victoria, increase in the number of hot days from 1960s, 70s up through to 2020. And we'll talk a little bit about that. So it's hotter on average, more hot days, and certainly some increase in extreme days above 40. And we'll talk more about what to expect in future. The anomaly, this is just the frost, later and more frequent frosts, so Mangalore and Tatura here. But basically this is April, May, June, July. You can see the months across the bottom there. And the red here is actually just showing in the recent 30 years the number of frosts that are occurring by each week of those months. So you can just see that extended frost season, which is largely coming with those seasons where we have drier air above our heads and clear night skies. It tends to be a bit more conducive to frost. So it can be warmer during the day, but then you can still get hit with the frost at night. I like talking about this. As you can see, here we are down here in Southeast Australia. They talk about the big climate drivers that have driven all of our climate variability, and they're going to play a key role in our future seasons and rainfall as well. We have, the El Nino Southern Oscillation. The trade winds blow towards Australia. A lot of the moisture that falls as rain above our heads starts off as a lot of this tropical moisture in the warmer oceans to our north, and it comes down to visit and falls out on the ranges, gives us pretty reliable rainfall. So the El Nino Southern Oscillation, it has sort of mood swings, and you can see some years of recent, the La Nina year is when these winds are blowing stronger towards Australia. There's more moisture up here in the Coral Sea, and that feeds into our weather patterns, which tends to correlate with wetter years. The Indian Ocean Dipole, again, some years there's more cloud and moisture just up in this part of the world, and it feeds in really good northwest cloud band activity, which correlates with wetter years for our part of the world. And so some years these two team up in the wetter phase. Some years they team up in the drier phase when there's an El Nino in the Pacific. There's no moisture sort of feeding in up here, and even the Indian Ocean dipole can be dry at the same time. They're years when we usually have higher fire and drought sort of extremes. And you can see down around south, the Antarctica there, these roaring 40s, the strong winds whiz around the Southern Ocean, and essentially the southern annular mode, really strong driver. It's the conveyor belt that drives all of these frontals, the cold fronts and frontal activity that sweeps across southern Australia. Really important triggers for rainfall, and we'll talk about how that's all a part of good old-fashioned variability, but some of these are changing due to climate change. Just looking at how some of these climate drivers have affected, so this is Alexandra rainfall, looking at 120-year rainfall record, a long-term average through here of 700 mils. You can see millimeters here up the side, 700. So, but you know, there's been years there where rain can be close to 400 and it can be over 1,000. So a lot of variability there. And what we have here, so that's 1900 through to up to 2020. These colours here are basically just years where there was a particular climate driver that was quite active, that was affecting the oceans and atmosphere that year. So what you'll probably can see, some of these really dry years that we have there all have something in common. They're all years when an El Nino was happening in combination with a dry phase of the Indian Ocean dipole, so a positive IOD they're called. So our bigger droughts are usually when those two misbehave together. And you can see often those wetter years, 2010, you remember an 11 big La Nina and the Indian Ocean dipole went into its wetter phase. So when they team up, their years, and you can see their influence on that sort of long-term rainfall record. Those years that are really a lot wetter than average tend to be when one of those climate drivers is in its wetter phase. You can see 2016 there, the Indian Ocean did that on its own that year. And you can see a couple of dry years there. 2018-19 was when the Indian Ocean dipole in its drier phase, and then the La Nina from last year. So you can see that their fingerprints are all over our wetter and dry years, and that's what sort of feeds into the seasonal forecast that the Bureau put out. But as well as you can see the annual rainfall deciles, this is from these two posters. One has temperature, one has rainfall. This has the 10 years of rainfall maps from 1910 to 1919, and you can see each decade is sort of summarized here. The bluer colours are where there's years that were wetter than average, and you can see 55, 56, 73, 74, 75, pretty wet years, big sort of combination of La Nina years, 92 there, that the 2010 and 11 pretty wet. So you can sort of see that variability, and the red colours are where they were, you know, much drier than average. So 2019 was an incredibly dry year, but you can see lots of variation throughout that long-term history in rainfall. If you take a look over here at that same record, but looking now at annual maximum temperatures and the temperature deciles, basically blue is the cooler than average years where temperatures were cooler than average, and the sort of yellows and oranges are where the maximum temperatures were warmer than the long-term average. So you can see there's a lot of variability there, but you just might notice a little bit of a trend that pretty much in the last 20 years, we're sort of spending much more time in much warmer than average territory. And that again is a trend that's expected to continue, and we'll talk about that. These are just maximum temperatures for southeastern Australia. This is from the Bureau of Meteorology, and I've just split it out, the summer maximum temperatures versus the autumn and the winter and the spring maximum temperatures. So you can sort of see a lot of variability from year to year, but in the last sort of 15, 20 years, more often are we above and warmer than average. So that trend's expected to continue. What you'll probably note though is just on some of these particular on the scales, spring is one season that's warming up. We've had quite a lot, and if you look at the last sort of 10, 15 years, we've had pretty well only 3 springs that were close to average or a bit cooler. So last spring was one of them, notably. But what tends to happen is if we have a much warmer spring, it's a bit like having summer arrive a month earlier. So we can still perhaps get away with that if we've got good spring rainfall, but in dry years, with that increased temperature, we just start the summer season a bit earlier. And that's probably a good way to think about climate change is we've snuck in an extra month of summer from a temperature point of view. And over time, that summer season will be basically getting bigger, which is something that has implications for tree growers. So what's this all about? Some of you will have heard about the carbon dioxide long-term trends. You can see since 1960, this is as measured out in the middle of the Pacific at Mauna Loa Observatory at Hawaii. Goes up and down each year, but here's this trend going up, largely caused by emissions and the burning of fossil fuels, and still going up pretty quickly. So there's a global effort to really look at how do we try and flatten this curve. Now, why is carbon dioxide and greenhouse gas emissions a problem? This is pretty old science. It goes back to the 1850s. There was Eunice Foote and also John Tyndall were both doing experiments on gases from the atmosphere at the time, and that's where they discovered that gases like carbon dioxide and methane, water vapor, they actually trap heat. And so from that early time, they knew that if there was more of these heat-trapping gases put in the atmosphere, what happens is energy comes from the sun that heats up the landscape, it radiates out its heat, and if we put more of those heat-trapping gases there, it'll slowly warm us up in here, and then in the outer atmosphere, they said we should start seeing things start to cool out there, and that's largely what's been observed now for a number of decades. And now the question is really just how warm it gets down here on Earth is all to do with this energy exchange ratio and how many, what's the amount of greenhouse gases we put there. So it's game on, and that's why there's a lot of work that's been done to really work towards long-term emissions reduction targets, and tree growers can play a key role in that. This is just from the Bureau of Meteorology and CSIRO, looking at the last sort of 100 years of temperatures, and you can sort of see the projections going forwards. One of the interesting things with all of their climate models, they can only simulate this increase in temperatures if you add the increases in greenhouse gases there. If we didn't have that, we'd still be in this original range. So we're off into new and uncharted territory. That warming trend will continue. There'll be a lot of variability around that, but the key point is where we are now is just about, well, how much might it warm in future? And this is just looking at where we are now. This is looking at 1850 through to the year 2000 and 2050. The black line there is sort of observed temperatures. But just to put in context of where we are, there's really high confidence around the role of greenhouse gases in trapping more heat. This big question, though, is about what will humans do in the coming decades? It's really not exactly clear. The challenges before us, and a lot of the climate change projections, this is looking at potential future temperatures. This is the year 2100, which is often projected, and you can see the difference between, you know, a 1.5 or 2 degree increase versus a 3 or 4 degree increase. But important from a heat trapping point of view, what greenhouse gases we put in the atmosphere in the coming sort of 3 or 4 decades, they'll have an impact for a few centuries' time. So it really is a critical time in history, and about whether humans are up to the task of reining emissions in and keeping the sort of longer term temperature projections in check or within a range that we can handle. Now, I really like this quote: climate is what we expect, but weather is what we'll get. So what I'll explore in the next few slides is just really looking at the future climate change projections, but also teasing out some of the things and what it might mean for those of us growing trees. Just one of the key things when we're looking at climate change, what are the big changes? Well, if you warm up the planet, what happens is that the tropics is the hottest, warmest part of the planet, and basically the tropical zones expand, either side of the equator, and it nudges all of our weather systems and climate zones towards the poles. Happens in both hemispheres. So what that means for us in Victoria is that, you know, these westerly driven winds in the Southern Ocean that drive all the cold fronts, they'll be sitting further south, and a lot of the moisture that and the rainfall that sort of comes from that frontal activity will be happening further south. So that's why a lot of Southern Australia has a bit of a drier signal in the future climate change projections. Also, 90% of the extra heat goes into the oceans. So when the oceans and all the extra heat is over an part of the equator, we can expect some years to be bringing extra moisture and wetter. So it's essentially, well, on things will be warmer on average, we'll also have basically stronger extremes when we're at the drier and the wetter end of the scale. And just to give you an idea of that, this is from the recent Victorian climate change projections, and they looked into, well, what might future extreme heat days look like. So this is a simulated extreme heat day in the 2050s. So if you're planting you know, a 30-year rotation of trees today, this is the sort of thing that will be happening around harvest time. So you can see the temperatures here up the side. This is temperatures, you know, 47 above 51 degrees, the darker colour. So daily maximum temperature for an example extreme heat day simulated under a very high scenario. So that's if we continue with high emissions as we are now. This is where Melbourne reaches 50 degrees and even higher temperatures inland. So they're saying there's a bit of a warm bias, they suspect, here in Gippsland, but they're saying this is not the hottest day in simulations, it's just indicative of a very hot day in the future climate without historical precedent. So when you hear about a lot of climate change projections and, you know, the planet warming up by, you know, whether it's 2 degrees or 3 degrees, but the actual increase in extreme weather is what will affect our crops and our trees a lot. So hence, when you see things like this, there's a lot of effort going into, well, how can we start reducing emissions as quickly as possible, because that will avoid the worst of these sort of future impacts. Another thing with climate change projections, they do a very good job at the broader signal of things getting warmer and some areas, in Southern Australia being drier. But even if we are dry on average, rainfall intensity is something that there's pretty strong confidence that rainfall intensity will increase. And this is some work with Seth Westra and the crew looking at rainfall intensity. And this is just looking at two sort of storm cells. And the blue is a storm cell at a cooler temperature. This is a storm cell at a warmer temperature, and it's showing where all of that rainfall falls out. So you can sort of see here, this is the amount of precipitation. This is the distance from the center of the storm cell. And at warmer temperatures, basically more of that moisture falls out in a tighter cone. So that sort of explains why, you know, we expect to be seeing more increased intensity in rainfall. And one of the things, I guess, that comes with that with storm bursts is that often there's some high winds and things associated with those storms. So that's just, you know, with what happens when you have an atmosphere that's got a bit of extra energy, it's more charged up. So something to keep an eye out for. Just looking at this for temperatures, if you see, if someone talks about being 1 degree warmer on average for the whole of the year, these are the maximum temperature 1 degree ISO heights for Victoria, and you can see, you know, that you've got to go usually about 100k to find somewhere that's already 1 degree warmer for each day of the year on average. And for altitude point of view, if you're looking for somewhere that's 1 degree warmer, you normally need to go down in altitude about 100 meters. But basically, you can see that temperature is quite a big range there. Has a big impact on the type of trees and species and forests that grow. One key thing though too is climate change will be happening right throughout the next century. So from a tree growing point of view and with agroforestry, at least if you have a rotation every 25, 30 years, you have a chance to reset and sort of think about what's best placed for that environment to plant going forwards. Fire risk is a key issue for when tree growers and looking at plantations and agroforestry. This is just showing an increase in the number of dangerous fire weather days that's been measured. Basically, an increase in the number of those high fire danger days since 1985 compared to looking at, say, the 1950-1985 period. And so that's as you would expect it, and that'll continue as basically we have that increasing temperature signal and the bigger summer that gradually settles over southern Australia. Just looking at fire management, this was sent by some researchers in Melbourne Uni, but the count of severe wildfires in our forested areas since 2000, and you can see some areas have been burnt not only once, but twice, three, and even some places burned up to 4 times since 2000. So in the last 20 years, some of the sort of forest ecologists are saying we're potentially seeing a bit of a regime shift in the incidence of fires. And I guess the broader challenge is for anyone involved in trees is that making sure that you're really planning well for your fire protection and management when you're doing that right from the word go at you're planning your tree project. Wind often gets talked about what's going to happen in the future with wind. Best probably say when you look at the climate change projections for Victoria, it's not well resolved. Largely it says a large scale pattern suggests we should be expecting slightly less wind because especially some of the high winds in the Southern Ocean will be a bit further south. But I guess the key uncertainty is around the extreme gusts and downbursts and things that you might get with extreme storm activity. And this is just looking at some of the big weather events last year in 2021. There were a couple of storms which brought down a lot of trees in some of our forested areas. This is up in the Wombats, and I noticed there was an Ozflux tower, which are tall towers which they have to measure gases and temperatures in the canopy of the trees, that it was knocked down in the Wombats, and the Ozflux tower in Tasmania was also knocked down in those winds last year. So a bit of a question mark over what to expect with future winds. But so windstorm is still going to be around as a risk. When we talk about climate change, I like to think about the 3 P's of climate change. So I've talked a lot about the physical effects of weather, but there are other impacts, and one of the impacts is around the changes that can happen as climate change is considered in various policies, such as reforms around water planning or carbon and emissions trading or energy, renewables, bushfires, or planning activities. A lot of that has an impact, and so when you're looking at businesses, it's important not just to think about how the weather might play out, but also how some of these policy changes can impact on your business. Also, a really key one that's changed a lot in the last 10 years has been around how others respond, such as how banks are responding, investors, insurers, consumers, and trade supply chains. There's a big change there, and a lot now that especially looking at committing to the Paris targets, to the looking at emission zero by the year 2050, and then actively looking at, well, how can they reward that and find things that are much more lower emissions in their supply chains. So stay tuned. I think there's a lot of opportunity in that for people that can do that well. Just looking at that challenge too, because here's California, their emission story since the year 2000. One of the things, I guess, basically that's happening and across all economies, looking at how do we have a high functioning society going forward, and this is showing GDP growth, but also a lot of policies being enacted to tease away that growth of the economy, but now reducing emissions. So that is the challenge that's set there before us, and finding ways that we can still have a lot of economic activity, but we're doing it in ways which has much less emissions associated with it. So there's a lot of potential positives there for those that are in the business of growing trees, which is all about bringing carbon down, capturing in the atmosphere and bring it back down to earth. The Victorian government's got a climate change strategy. Here's the website here if you want to go and get the latest on all of that. Just as a quick summary though, the Victorian government's got a target of net zero emissions by 2050 and looking at a sort of 45 to 50% emissions reduction by 2030, and that's below 2005 levels. Interestingly, in 2019, Victoria's emissions fell to 24% below 2005 levels, so we're on the way. So there's a lot of activity happening there, but there's plenty more work to come. When we talk to farming and look at land use, and there's lots of areas for action and reducing emissions and adding carbon into our landscapes, and we talk about the 5 action areas. So it's all around renewable energy and less fossil fuel emissions, the role of trees and more carbon in the landscape, soils as well, and protecting what's already there is important. It's hard to increase soil carbon, but important to protect what's there. A lot of work going on in the livestock area with methane, and also looking around nitrogen and nitrous oxide in systems. But there's a lot of actions and activities that are already being done, and a lot of work going into how we can do that better. Also, just a note, there a lot of discussion with tree growers around carbon targets, and I ran a carbon sequestration scheme back in 2003 with share farming schemes with farmers, and can tell you all about that. But also what we learnt too, some really key questions. When you look at planting trees, you have, as your trees grow, they accumulate carbon, but eventually you sort of get to maximize the amount of carbon on per hectare. So if you're talking about carbon credits, you can generate potential income while you're accumulating extra carbon on site, but at some future date, you basically carbon income will stop. So really important that you understand what's associated with carbon and carbon agreements. And we've got a friendly note and an ag note there on our website on questions to ask before you sell your carbon. So I just suggest you make sure you know what you're getting into before you enter into any carbon contracts, because often you could be locking in a price at today's price, but understanding who wears the future risk if you are looking at things like future fires or what have you, or even with changes of land ownership. There's some pretty important considerations to make sure you know what you're signing up to. I like showing this story because I guess bringing carbon down to earth and putting it to good use is what good agroforestry is all about. And you know, here we go, taking carbon out of the atmosphere by planting up, you know, a regional area of agroforestry, and taking some of that timber out and putting it into buildings is actually a really useful thing to do. And then you can regrow it again, take more crops out. So if you think of a 100-year cycle, if you had a 25-year rotation, you can potentially take 4 crops of carbon out of the atmosphere and put it into products that's then displacing other products that might take emissions to manufacture. So wood has a hell of a lot going for it. It's also really interesting that some of the wood residues and things can be used for all sorts of things, can be used for bioenergy and also, but you might hear a bit about biochar, and actually interesting with pyrolysis is one potential opportunity for tree waste. That biochar basically takes a shorter term of carbon from wood and puts it into a type of carbon that could be around for 1,000 years. So that then can create a carbon credit scheme. And if I was looking at setting up a business, it would be around, have income from wood selling and then regrowing the wood and the timber, but then looking at carbon credits that's associated with a biochar type situation, which has a much less risk to it than trying to sell carbon credits from the trees, the carbon in your trees. So keep an eye to that. There's lots of business opportunities coming, just a matter of the potential policies and business environment that can make all of this happen and encourage it. So the challenges before us in the next couple of decades, can we actually flatten this curve? It's a global effort. Every part of the world's got to do their bit. Every region's got to do their bit. And congrats, because I think Master Treegrowers are certainly doing their bit. I just sort of finishing off here now that there's talking about the landscapes and the sort of places of where we want to live. And often refugium is often what we refer to when we're talking about ecology for our flora and fauna, but I think it also includes us. Refugium is an area in which population of organisms can survive through a period of unfavourable conditions. We've got plenty of challenges coming our way, and we know that with some of the changes I've talked about with climate change, but also, we can still create really great landscape and places that are great places to work and live. We've got to be well prepared. There's a lot of work we've got to do to make sure we're considering fire and flood management. But there's lots of great R&D and technologies and lots of things that we're blessed with that if we use that well, we can create great places to live. So I think that's all before us. Tree growers can do a great part of this, but it's all with just considering some of these things that we need to do it to plan well. Also, just going to make the point that successful agriculture and agroforestry occurs across many climate zones. So a changing climate it presents some challenges, but it actually doesn't mean that we can't set up some really good productive systems that can cope with some of these changes. So that's why it's important to just think ahead. Each system, though, in different climates has a system that works for that particular region, and the soils and infrastructure and the particular farm or agroforestry system. So that's why it's worth looking around. There's a lot to do with learning from others, and I think teaming up and being part of groups like what you're doing there is exactly the sort of thing we're going to need, and sharing learnings and adapting as we go. So a lot of a powerful role for leadership. Essentially, most of this is around making decisions today that leave us better off in future. So good luck with your planning and the rest of the program. I like to show this little slide from Joel Pett. It's basically just about that mindset of, well, let's just get busy and make sure we've got good evidence-based solutions and we're getting on with it and building better places and communities to live. So all the best with the rest of the program. Got my contact details there if you'd like to give me a call at any time, and hope to see you around. Thank you.